In this video, we'll be looking at section 2.5, graphing vocabulary. And our essential question will be, how do I identify the different intervals, domain, and range of a graph? So the first thing we'll want to do is find all our definitions, and we'll do that by just writing them out. So our definitions, the first definition we're going to look at is our domain. And our domain is all possible x values that satisfy the equation. For quadratics, this is always all real numbers, which I'll use this symbol to identify. So this symbol right here, this R with a line through it, is our all real number symbol. So anytime we're asking about the domain of a quadratic, we automatically know it's going to be all real numbers. Our range is all the possible y values that are outcomes of the equation. And for quadratics, y will be less than or equal to the y value of the vertex, and or y will be greater than or equal to the y value of the vertex. Next, we have our maximum point, and that is the highest point on the graph. And then we have a minimum point, which is the lowest point on the graph. Next we have our intervals. So I have an increasing interval. And the increasing interval is the x values that give me increasing y values. And then we'll have decreasing interval, which is the x values that give decreasing y values. Okay, so there's all our definitions. Let's do a quick example, and then we'll be done. So first we'll need to have a graph. So I'm going to draw my graph over here to the right. We'll put our vertex at 2, 4. Let's put our y-intercept at 2, x-intercept at -1. Okay, looks good. And then we'll draw our parabola. Like so. I'm going to label these points so we have clear numbers to see. My vertex is 2, 4. My x-intercept will be 1, 2, 3, 1, 2, 3, 4, 5, 0, and then -1, 0. And then our y-intercept is 0, 2. So the domain is all the possible x values. And if I think of this graph as going on forever and ever, I will eventually, even though it looks like it's going down, it's still going flaring out just enough that all x values are possible. So that is why the domain will always be all real numbers for quadratics. Specifically for quadratics, the domain is always all real numbers. And then our next piece will be our range. And I'm looking for all the y values. Well, we know in quadratics, all our y values are either less than a value or greater than a value. So when I'm thinking about all the possible y values, I go, well, this is my top y value, and there's no y values above it. So all of these y values that go below it are different y values that are less than our 4. So, but we can also equal 4 because that point exists. So I would say my range is less than or equal to 4. And I'm using this 4 right here to kind of define that, the 4 of the vertex. Next, we'll talk about our point, our vertex point. Our vertex point is 2, 4. And we can write that sentence that states the max is 4 when x equals 2. So we've identified our maximum point occurring at our vertex, and then we've written some information about that. And then our increasing and decreasing intervals. So where is this graph increasing? Well, I need to use x values to tell me where the y values are increasing. So I travel the graph from left to right, and as I'm traveling the graph, I'm going up. So my y values are increasing. But how would I state the x values that define that? So am I increasing right here? Well, I will state the x values that are less than 2. So when I have any x value that's less than 2, my y values are increasing. And then for my decreasing, we're going to use the same idea. So I'm decreasing once I pass 2. So what x values give me a decreasing? Well, those x values would be the x values that are greater than 2. And so this number comes from our vertex as well. So here we have our domain, our range. We talked about our maximum, and then we talked about our increasing and decreasing. So that is how we can use our vocabulary to give us like kind of more information about the quadratic function or the parabola graph. Well, thank you very much for watching this video, and I hope you have a great rest of your day.